Welcome to this learning journey on Assessment for Learning, a cornerstone of effective teaching in electrical systems and control. Assessment for Learning, AFL, is a vital component of the teaching process as it allows educators to gauge students' understanding and knowledge of electrical systems and control. By using various strategies, teachers can identify areas of strength and areas that require further support. The goal is to measure what students have learned and provide them with opportunities for feedback and improvement. This can be achieved through formal and informal assessment techniques, encouraging students to engage with the content and reflect on their understanding actively. Assessment strategies in electrical systems and control include formative assessments for feedback during the unit. Quizzes and short tests check knowledge of basic concepts like circuit diagrams, voltage, current, and resistance. Examples include quizzes with multiple choice and short answer questions on electrical components, such as explaining a resistor's function or drawing a simple circuit. Exit tickets are used to assess student understanding at the end of a lesson, where students might write down one key takeaway or answer a question like how an electrical circuit works, allowing the teacher to determine if further clarification is needed. Concept mapping evaluates students' understanding of the relationships between different concepts in electrical systems and control. For instance, students might create a concept map showing the flow of electricity through a circuit, including components such as the battery, switch, wires, and bulb, along with terms like voltage, current, and resistance. Practical assessments involve hands-on activities that let students showcase their understanding by applying concepts practically. Lab activities serve to evaluate students' ability to apply theoretical knowledge in a practical setting. For instance, students might be asked to construct a simple circuit using a battery, wires, and a light bulb, with teachers assessing their skill in assembling the circuit, identifying and resolving issues, and explaining the circuit's functionality. Project-based assessments focus on students' capabilities in designing, building, and explaining electrical systems, such as creating a simple alarm system. These projects are evaluated on creativity, functionality, and correct use of electrical components. Peer assessment fosters collaboration, enabling students to learn from one another while reflecting on their understanding by evaluating peers' work. Group work and presentations aim to assess teamwork, communication, and technical knowledge. For example, students can work in groups to research and present on various electrical systems, such as home wiring or solar power systems, with peers assessing each other's understanding based on accuracy, clarity, and teamwork. Peer review of work allows students to reflect on their learning and learn from each other's mistakes. For instance, after completing a worksheet on circuits, students exchange and review answers, providing feedback on accuracy and clarity to reinforce learning and correct misunderstandings. Encouraging students to reflect on their learning fosters self-regulation and ownership of their educational journey. Self-reflection journals serve the purpose of prompting students to think about what they have learned and identify challenging areas. For instance, after a unit on electrical systems, students might write journal entries about their understanding, difficulties encountered, and where they need more assistance, enabling teachers to provide tailored support. Checklists are designed to help students assess their progress and ensure mastery of key concepts. An example would be giving students a checklist with skills like drawing and labeling a circuit, or understanding the difference between series and parallel circuits, allowing them to self-assess their proficiency in each area. Summative assessments evaluate overall understanding and learning outcomes at the end of a unit. The end-of-unit test aims to assess the cumulative knowledge of the students on electrical systems and control using a mix of multiple choice, short answer, and diagram-based questions on circuits, components, and electrical concepts. Project submission assesses students' ability to apply what they have learned in a larger, comprehensive task. Students submit a detailed report on a project where they created a working electrical system, such as a basic circuit that turns on a light. The project is assessed for technical accuracy, creativity, and the ability to explain the process. In conclusion, assessing learners' understanding of electrical systems and control through various strategies is crucial for educators. By employing formative assessments, practical activities, peer and self-assessments, and summative assessments, teachers gain valuable insights into students' knowledge and skills. This comprehensive approach ensures that learners receive continuous feedback and opportunities to demonstrate their understanding in diverse contexts. Such strategies not only help gauge academic progress, but also support students in honing the critical thinking and problem-solving skills essential for mastering electrical systems and control.